Hi, welcome to the last session of the Open Security Summit December virtual edition. And what a great way to end. We have Clint Gibler, who's going to do a presentation about what I think is a very exciting new sort of entrance on the whole static analysis sort of world. And if you know me, I'm very passionate about static analysis. It's all about graphs, and I've been in this industry for a while. And I've always been very frustrated on the lack of innovation on that part of the security world. And what I want to call out is that these guys are, they are almost a modern company in a modern environment where they have an open source engine and an open source rule base, which I always kind of felt that it was what's needed to really accelerate the use of static analysis and expand on it. And the company he works for is basically funded, has a nice business model, which is based about providing services around it, which I think is the way to do it, because commercially that's what I would like to engage with. And I think it allows for now a lot of innovation around the engine and the rules. And so everybody enjoy it. And I really want my team to also be actively involved, and we hope there will be contributors to this. And this is going to be the first of many sessions at the Open Security Summit around Semgrep. So Clint, over to you.
Cool. Thank you so much. And thank you for the invitation. I'm really excited to be here. So I guess this talk has sort of like a couple of parts. So one is a lot of the workshop is going to be just like hands-on exercises. Hopefully, we'll all be writing some sort of custom security checks together. And then the other part of it is just some sort of ideas how myself and others view the world, because I think it's sort of useful context. I think it's nice to sort of start off with a sort of an ambitious claim. So I think by the end of this workshop, you're going to, from scratch, learn how to write Semgrep rules. And I believe you're going to learn to do that well enough to find bugs unique to your company. So I think you're going to walk out of this and say, oh, there's this one, wonky thing that my code base for my company happens. Like, I want to ban all of those. I think you're going to be competent enough to do that. And if you have any trouble, just hit me up. I'd be happy to help after this. And we're also going to show how to get this coverage continuously in CI. So this is, a lot to claim perhaps for just one session, going from zero to doing something immediately useful, but I think we can do it. So just to give you some highlights, we're going to write some sort of custom lightweight checks to find either dangerous or functions you want to ban. We'll find injection issues like cross-site scripting. We'll look at extracting like attack surface, for example, all the routes from a web application. We'll find some business logic flaws, so things that are not sort of generic, across top 10, but are like really sort of specific to one application. And one thing that I'm particularly excited about is we're also going to show how you can provide an auto-fix suggestion for identified issues. Here's an example of what it might look like. So many security tools can write sort of comments on pull requests on GitHub or other platforms. And here in this workshop, we're going to show how you can use the GitHub like suggestion API to say, hey, this route does not do a JWT auth check. Let's like auto recommend, hey, here's what you should add, so that a developer can just like click it and then apply it. So pretty excited about that. And we're going to be writing rules across a bunch of languages. I believe Golang, Java, Python, JavaScript, and Ruby. So we'll do a little bit of a lot. Okay, so here's the workshop in a bit more detail. So first, we're going to talk just some like high-level ideas about like why are secure defaults so powerful, and we'll look at a bunch of very prominent tech players who have embraced them. Then I'll give you a little background about what Semgrep is, and sort of like why it's useful. And then all these sections in blue are going to be hands-on exercises. So we're going to be doing some like intro rule writing. Then we'll talk about a methodology for how to tackle bug classes in your organization based on a talk my colleague Isaac and I gave at Global AppSec SF. Then we'll integrate it in CI, and then we'll do some like advanced rule writing if we have time. Okay, so one thing that I would love from you all is if you just know, or if you can think of during this workshop, just some code patterns in your organization you'd like to find. I would love to help live write some rules together to find those. So ideally, I would love if the end of this, like the last maybe half hour, was just like totally us. You send me something and then we like try to find it together. So I think that would be more exciting than just some examples I have prepared, because then we can sort of show the process of trying to solve problems together. So let that like noodle in your brain a little bit as we go. Okay, super brief background about me, in case you don't know me. So my name's Clint. I am the head of security research at R2C. We're a small San Francisco-based startup. This is our obligatory Zoom pandemic company photo. Before that, I was a research director and technical director at Semgrep, which is a global security consulting firm. So I was doing pen testing as well as helping advise companies on how to scale their application security program, how to embrace DevSecOps, things like that. And before that, I was a indentured servant / grad student at UC Davis. So feel free to reach out on Twitter. I also have a security newsletter called TLDRsec, where I basically read a ton of articles and try to summarize the best ones, the best tools, the best new research, so that you can sort of more easily keep up with what's going on in security. So feel free to check out that as well. Okay, so let's talk about why secure defaults are so powerful. So I think that there's been some significant shifts in tech in the past 5-10 years, maybe 15, right? So we've gone from waterfall development to agile, from separate dev and ops to DevOps, and from on-prem to the cloud. And obviously different companies, move at different paces, but I think this is overall sort of a shift we've seen. And I think security is specifically also going through a shift as well, that it's still early on, but I see significant evidence of this a lot of places. Before, there was a big focus on how do we find all of the vulnerabilities, and going forward, I see a number of companies focusing on like, how do we give secure defaults, like secure primitives, some sort of a paved road approach that developers can follow and easily and transparently do the right thing without necessarily needing to always be aware of security. So I have a sort of a thought experiment for you. Let's say I were to give you a random web application that you've never seen before, and I asked you, does this app have cross-site scripting? So probably you'd have a lot of questions, right? You'd probably say, well, okay, so, what does the user control? What's the structure of the data that they can pass in from the web application? Does the web app filter the input in some way? How is it stored in a database? Is it stored as like an integer or a float or a string or a Boolean, maybe arbitrary JSON? Maybe the database type matters, MySQL versus Postgres and so forth. The data that's returned from the database, how is it processed? Do we do some sort of like filtering? And then when that data is sent to the user's browser, how is it included? Like, is it just directly put into HTML or an HTML attribute or JavaScript, maybe CSS and so forth? So before you can make an informed guess at, how risky this application is with regards to, say, cross-site scripting, there's a lot of questions you probably have. But what if I were to instead tell you, we've enforced this secure default for this application. The front end is entirely React, and we've banned the function dangerously set inner HTML, which is basically a way to opt out of React's default output encoding, such that you're like, hey, I know what I'm doing, like, don't protect me. So because React is such a strong, well-built front-end framework, basically, if we can guarantee that this assumption holds, probably all of these other things are significantly less important. It's a lot less risky. And basically, I think of this as sort of two sides of the same coin, right? So ultimately, we're trying to improve the security posture of our application and reduce our risk to the business. And on one side, it's like, okay, well, can we find all the bugs? And then the other side is like, oh, if we just only use this safe way that we've sort of, rigorously vetted by the security team, and we know that it is safe by construction, then, we might not actually have to do all of this bug finding in the first place. Another way I like to think about it is, for what task we're trying to perform, like how much effort does that require? So the y-axis is in CHUs, or Clint's hand-wavy units. And so in the bottom left, detecting the use or lack of use of like a secure or insecure library, like that doesn't take a lot of analysis complexity, right? Like in many cases, that's just almost grep or a little bit smarter. But if you want to find something that's potentially a bug, that's a little bit more work. If you want to confirm something is a real bug, that's even more work. And if you want to write a proof of concept exploit that demonstrates that issue is actually exploitable in practice, that's even more work, right? So like each of these things is getting harder and harder, but ultimately, again, it's not about finding bugs, it's about how can we reduce risk. And fundamentally, what I'm getting at is, detecting the use or lack of use of secure defaults is just much easier than finding bugs. It's like, how can we solve like a simpler problem that still gives us the security and safety benefits that we want? In case there's some young people in the audience, I wanted to include a meme so they could relate. Broke is trying to find every vulnerability, and woke is trying to prevent classes of vulnerabilities from happening in the first place. One thing that I think is useful is like, okay, these FANG companies, Facebook, Apple, Microsoft, Amazon, Facebook, like all these people with, super large budgets. They have big security teams with really smart people. They have executive buy-in for security. They are willing as an organization to pursue these long-term strategic initiatives. They've thought about this a lot. I think it's illustrative to look at like, okay, what are players like these doing? Because they have, at least compared to my company and a lot of companies I've worked at, they have a lot more resources, right? So what are they doing? Because probably we can take some inspiration from them. So this was a great talk by Scott and Isha of the Netflix AppSec team at AppSec Cali. And here we can see a couple of things they're focusing on, like secure by default, self-service security, and security partnerships. And we can see that this emphasis on secure by default is actually growing over time. Microsoft had an interesting study where they found that 41% of the vulnerabilities reduced from migrating from XP to Vista was basically just banning dangerous functions like stir, copy, and others. That's a pretty good win for just some greps, in my opinion. This book, Building Secure and Reliable Systems by Google's security and SRE team, is actually freely downloadable online. I encourage you to check it out. But it had some very interesting chapters on secure defaults. And one quote that I like in particular is, it's unreasonable to expect any developer to be an expert in security, like as they're doing their job, and be constantly vigilant when they're writing code. A better approach is to handle security and reliability in common frameworks and languages and libraries. And ideally, these libraries make it so that writing code with these common classes of security vulnerabilities impossible. And I really like this because we expect developers to create business value, to write new code that is performant and scalable on a tight time schedule. And that takes significant expertise that I think many of us as security professionals, or at least I, don't have. So to expect them to also be security experts, which again is like another area that takes probably also years of study, I think is a bit unfair. And so that's why I like that. This blog post by Facebook, where they describe, we invest heavily in building frameworks that help engineers prevent and remove entire classes of bugs when writing code. So in this blog post, they have basically an inverse pyramid where at the top they have secure frameworks, which ideally handles as many bugs as possible. And then they also do, automated testing tools and peer reviews and so forth. So all of these things have a role and they're all valuable, but sort of the base of the pyramid, the thing that they're trying to get the most leverage from is secure frameworks. And here's an anecdote, sort of off the record. This was told to me by a friend at a hypergrowth Bay Area startup who said, we were concerned about RCE and our Node.js apps, so we just banned eval, new function, and other ways to just run arbitrary JavaScript. And basically, they wrote some custom ESLint plugins that ran on every pull request. That basically, if a developer used one of those, it just said, you cannot merge, please remove this. And then basically they didn't have to worry about these types of issues in their Node.js apps. One thing he said that I thought was a bit funny is you can get amazing security wins if you can be a bit draconian about your coding standards. And of course, there's a big caveat here, right? You need sort of organizational buy-in. You can't do something the engineering team is unwilling to follow. And ultimately, the security team needs to support company goals and not just sort of be naysayers. But that being said, this, I think, mindset and this approach can be quite powerful. Okay, so that's just a little bit on what I've observed many companies doing that they found very effective, and why this is the angle that I personally believe is the future of AppSec, and why this is the angle that we're trying to embrace with Semgrep. Okay, so a background about Semgrep, but soon we're going to hands-on write some rules. So just some background, like why do we need Semgrep? Why don't we just use grep? Because grep is an awesome tool. Okay, so let's say we want to find some particular dangerous function, let's say exec, where if an attacker could provide input, maybe they can execute arbitrary code. So this is scary. So let's look at a couple of ways this could manifest in code. So we could call exec on some sort of string literal. We could call it on a variable. There could be some white space and so forth. So let's say we were trying to find these with grep. So the first thing is like pretty easy. We could just do exec open parentheses. That would work for the second as well. The third example, we have to start matching some white space. That's a little less easy. Then it could be on multiple lines. So we'd have to do some like multi-line regex. Like that's a little bit messier. It's probably going to be hard not to flag this example. It isn't the function we're looking for, but it does look like it. And then these last two examples where we're, inside a comment or inside a string, like that's going to be very hard to match with or it's going to be hard to not match that with a regex. So that would be a false positive that's going to clutter up our search. So obligatory xkcd. If you're having Perl problems, I feel bad for you, son. Got 99 problems, so I use regular expressions. So regexes can get you a lot of the way there, but they're difficult to maintain. And as we just saw in the previous example, it's difficult to express complex code patterns with grep. And the reason for that is regexes and grep treat code like a string. It's just like these are characters. But ultimately, code isn't a string, right? It's a tree or a graph. And that's actually how interpreters or compilers view code, right? Because they need to build some understanding in terms of like, okay, this is an annotation, this is a function definition, this is a method call, and so forth. So tree matching or abstract syntax tree matching is not new. There's lots of tools that do it, both just linters as well as security tools. So for example, Bandit, DLint, and so forth. But the problem with all these tools is they all represent abstract syntax trees or code differently internally. So if you in your organization use more than one language, you basically would have to learn how all of these tools represent code. And also there's many different ways to express the same semantically similar thing in languages. So it can be a bit complicated to cover all the edge cases. There are obviously powerful commercial static analysis tools that do these things quite well, but they tend to be a bit complicated to get started. Some of them can be a bit slow, and they're also sort of pricey. Here's an example of an ESLint rule on the right-hand side, where it's like find all calls to eval, and that rule is 307 lines of code, including comments and whitespace, but still, that's a lot to write for just like, hey, find eval. So ideally, we want to be able to do this more easily. Which leads us to Semgrep, which is a open source, lightweight static analysis tool. My company, R2C, is building it, but it actually has an interesting history. So we didn't actually create it. It was originally created by Facebook, specifically Yoan Padalu, who is the first program analysis hire at Facebook. And at Facebook, they used it, originally it was called Puff. And they used it to enforce nearly 1,000 secure coding rules internally. So we actually ended up hiring him last year, and we rebranded sgrep to Semgrep and have been building it and adding features ever since. Yoan actually, during his PhD at INRIA, worked on a tool called Coccinelle, which you may or may not be familiar with, which is basically a pretty neat tool that was used to submit a bunch of patches and bug fixes to the Linux kernel. I think hundreds or thousands of bug fixes. So there's actually a long history here. It's not just this new tool, actually. Okay, so a quick summary of like features and like why do we care? So Semgrep is nice for security consultants and researchers in that it's open source. It's on GitHub. It's LGPL, so you can use it quite permissively. It supports many languages out of the box. These and others are constantly being added. There's over 1,000 rules out of the box that you can get started immediately. And also you do not need to have buildable source code. So if you have, say, partial source code or even just one file, or maybe you can't resolve internal dependencies, you can still use Semgrep, which is actually, if you're not familiar, a pretty big difference from every other static analysis tool that I've used, in which generally they need full buildable source code because they need to resolve functions and classes and types. And there's like a whole mess here that I can get into if you're curious. But I think the biggest thing here, and that's going to be the emphasis of this workshop, is there's no separate painful domain-specific language you need to use. You don't need to spend days or weeks figuring out, like, how do I use this tool? Basically, if you're trying to write a pattern to find Python code, you write Python. If you're trying to find Java code, you write Java. And there's like a couple of helpful abstractions, but really the patterns in Semgrep look like source code. And this is a key differentiator from other tools.
There's a question in chat. Does it support C# and C++?
Yeah, that's a good question. So C#, we actually have a member of the community who is in process of adding support for that language. So I would say not yet, but probably in the next 1 to 2 quarters, we'll have reasonable C# support, and C++, not yet. There's a bunch of reasons why C++ just as a language is hard. So we have gotten a number of asks for it recently. Oh yeah, that would be wonderful. Yeah, I'll send you a bunch of links after this. Feel free to reach out. But yeah, so I'd say C# progress is in progress of being added, but it's still going to be a little bit. And C#, I think we've like tested it, but we haven't really tried to roll it out yet. So still early stages for that. But yeah, we will be overjoyed to help you with adding support. That would be awesome. So yeah, thanks for your question. Okay, so for AppSec engineers and developers, one thing that I think a lot of us have found is, there's these like coding standards or expectations that are either on a wiki somewhere, or maybe just in our brain, or maybe in the code itself. And it would be nice to be able to enforce these continuously in CI, whether that's GitHub, GitLab, Travis, or whatever. And we'll show how that we can do that actually quite easily. Okay, so just to sort of like mentally put Semgrep on like the spectrum of static analysis in your brain. So on one side, the left-hand side, we have very simple things like regexes and grep. On the right-hand side, we have whole program analysis where we're doing control and data flow across hundreds of files. Basically, Semgrep is in the middle where we're trying to get some benefits of both. And I can like go into that in more detail, but that's basically the idea.